How to solve systems of equations without graphing using the elimination method. We will do 3 examples together. In the first example, our goal is to use the elimination method, which means we would like to eliminate one of the variables. We do this by adding or subtracting the equations together. So here we have a system of equations. Let's try adding them together to see what happens. If I add these equations together, I have 2x plus 2x is 4x. Now if I add y plus negative y, that cancels out, or the y's are eliminated. And on the other side, I have 4 plus 0 is 4. So we have just used elimination to eliminate one of the variables. And now we can solve for x because we have 4x equals 4. So we divide both sides by 4 and we have x is equal to 1. So we eliminated y by adding the equations. X is 1. Now I can solve for y by plugging x into either one of the equations. I plug it into the first one. 2 times x plus y is equal to 4. X is 1, so 2 times 1 plus y is equal to 4. So I have 2 plus y is equal to 4. Subtract 2 on both sides. Y is equal to 2. So my ordered pair, I have x is 1 and y is 2. So I have the point 1, 2 is the point where these two lines intersect, and that is the solution. So you can see with elimination, our goal is to eliminate one of the variables. This is easy when the variable here, y, we eliminated, had the same coefficient, a hidden 1 here and a hidden 1 here, but with different signs. So when we added them, they canceled out. We won't always have it so easy, so let's try another example. Here in this system of equations, I have 2x plus 3y is 0, and 8x plus 9y is 18. I look at my coefficients of the x. They're not the same, 2 and 8. I look at the coefficients for y, 3 and 9. They're not the same. So if I add and subtract, nothing will be eliminated. Therefore, I have to manipulate my equations. So we know that we can multiply a number on both sides of an equation and it won't change the equation. It keeps it same as long as we do it on both sides. So if we want to have the same coefficient, then we can multiply an entire equation by a number without changing the equation. So let's look at the x's. If I want my coefficients to be the same, I have 8 here, but 2 here, I can multiply this entire equation by 4. That will give me the coefficient I want because we'll get 4 times 2x is 8x. And then I have to do the whole thing. I have to multiply the 4 by every part of the equation. 4 times 3y is plus 12y. And 4 times 0 is 0, so that's equal to 0. So I multiplied each part of the equation by 4. I kept the other equation the same. And now I see that my x's have the same coefficient. They both have 8. However, they're both positive 8. So in order to eliminate, I need to subtract because 8x minus 8x is 0, and that cancels out. So I've eliminated the x's, and I need to subtract all the way across. So I need to do 12y minus 9y is 3y, and 0 minus 18 is negative 18. So I have that 3y is equal to negative 18. Divide both sides by 3, and y is equal to negative 6. So we've solved for y. Now to solve for x, I plug what I got for y into one of the equations. I can plug it into either one. I'm going to plug it into my original equation that I had at the beginning, which was 2x plus 3y is equal to 0. So let's plug this negative 6 in for y. So 2x plus 3 times negative 6 is equal to 0. 2x plus, that's negative 18, is equal to 0. if I add 18 to both sides to get rid of that negative 18, I get that 2x is equal to 18. And then I can divide by 2, I get x is equal to 9. So my x coordinate is 9, my y coordinate is negative 6, and the solution to the system of equations is 9, negative 6. Let's try one more. Here I have negative 2x plus 3y is 7, and 5x plus 8y is negative 2. I look at the coefficients of the x, they're not the same. For the y, they're not the same. So I need to manipulate my equations in order to get the same coefficients so that I can eliminate. Again, I can pick which variable I want to work with. I am going to pick to work with the x's. So since I can't multiply 2 by anything to get 5, I have to work with both equations. And the trick is I can multiply each equation by the other's coefficient. So I'm going to multiply this equation by 5 because that's the coefficient of the other x, and I can multiply this equation by 2, and that's the coefficient of the other equation. We don't need to worry about the negative for the 2 until later. So let's just multiply by these constants. So if I multiply each part here by 5, I get 5 times negative 2x is negative 10x. 5 times 3y is going to be plus 15y. And 5 times 7 is equal to 35. For the second equation, I'm multiplying by 2. So 2 times 5x is 10x. 2 times 8y is 16y. And 2 times, that was plus, and 2 times negative 2 is negative 4. So now I have multiplied both equations just by a number. Since I did it to both sides of the equations, I haven't changed the equations. I have just made them easier to work with. So now if I look at my x's, they have the same coefficient, 10 and 10. However, they're different signs. This is negative 10 and this is 10. So to eliminate them, the best thing to do is to add, because negative 10 plus 10 will help us eliminate that to 0. And 15y plus 16y is 31y. And 35 plus negative 4 is 31. So we see that if we divide both sides by 31, that y is equal to 1. So that worked out nicely. And now to solve for x, I can plug that in to either one of the equations. So I am going to take this and plug it in to the second equation. Why not? We can do it to either one. So I have 5x plus 8, and y is 1 times 1 is equal to negative 2. So 5x plus 8 is equal to negative 2. Subtract 8 on both sides. I have 5x is equal to negative 8. Negative 2 minus 8 is negative 10. Divide both sides by 5. I get x is equal to negative 2. So my x coordinate is negative 2. The y coordinate is 1. So the point of intersection is negative 2, 1. And that is our solution. Thank you.